Right, so we are looking at some past paper questions for binomial. Now we are actually looking at the questions, which is a great start. We are going to work through questions, same like we did last week, but only questions this time. So we'll talk a bit of theory as we go, but the focus is on the questions. If you haven't done binomials yet, then play along with or save this session for another day. So this is a classic basic question to start us off. Find the coefficient of x in the expansion of 3x minus 2 over x all to the 5. Worth 4 nice marks, so it's worthwhile knowing what you're doing here. Now remember, the big thing for any sequences in series, APs, GPs, and binomials, is that we're only calculating interesting terms. If I asked you for the 40th term of an AP, you're not going to write out 40 terms. You're only going to calculate the 40th term. So it's the same thing for a binomial. You're only going to calculate the term you asked for. It's just that for a binomial, instead of saying the 3rd term or the 40th term, we identify our terms by their x squared, x cubed, x to the 4. So it's by their exponent of x. So find the coefficient of x in this expansion. First, we need to find the x term himself. In order to find the x term, we need to figure out what's our value of r for our NCR. Now we have a neat little trick to do that. Some of you may be able to look at this and see it and you know it and you can carry on, then go for it. For those of you who look at it and think, oh my word, how am I going to do that? We have a for value of r. And what we're going to do is we're going to say this x in this first position, he is a normal x. When we put him into our formula with his 3, he will have the exponent of, in this case, 5 minus r, n minus r. When we take our x from our b position, in this case, he's an x to the minus 1, he's going to get the exponent that's equal to r. So we know that that's going to be the sort of situation for our exponents. We know we are trying to make a coefficient of x, so we know we're trying to make an x to the 1 term. Normally we wouldn't write the 1, but in this case we need him there. So if we simplify a little bit, we have x to the 5 minus r and x to the minus r equals x to the 1. Laws of exponents, x to the 5 minus 2r equals x to the 1. And now you can see why we did all that work with exponents at the beginning of the course. Because here we can say, therefore, 5 minus 2r equals 1. If our bases are equal, our exponents must be equal. But we indicate that we're changing from one equation to another. So 2r equals 4 and r equals 2. Now we know what our r value is for our NCR. So we can go ahead and we can actually calculate that x term. So for term in x, remember your magic formula. You should get to a point where you can do it out your head. So we would have nr, so 5, 2, a position, 3x, to the power n minus r, so to the power 3. B position with its sign, minus 2 over x to the power r. And remember, it's always worthwhile to take a step just to simplify each of these elements separately before combining them all. So 5c2 gives us 10. 3 cubed is 27, x cubed is x cubed. Minus 2 squared is 4 and over x squared. And there we can see our little magic starting to happen. So x cubed divided by x squared gives us x, as we had hoped. So we are looking for 10 times 27 times 4. That gives us 1080x. But now that question didn't ask us for the x term. They asked us for the coefficient of the x term. So our final answer, therefore, coefficient of x equals 1080. So if we pull up MF9 for a moment, just have a look at what you will have with you in your exam. This is what you get for the binomial expansion. So this one here is for A level. You're not going to use him. This one here is when you're expanding term by term. Okay, and that tells you how to calculate NR. So what you're actually going to be using at the end of the day is not on here. Okay, you can figure it out from it because you're using NR, A to the N minus R, B to the R to calculate a single term. This is your best friend for the binomial because at the end of the day, you are more likely than not calculating a single term of interest. So please, please, please bear that in mind. Heading back here then to carry on with more questions. The coefficients of x and x squared in the expansion of 2 plus ax to the 7 are equal. Find the value of the non-zero constant a. Okay, so what are we looking at? We are looking at one expansion. We're looking at two different terms. And we know that their coefficients are equal, so we can build an equation. Okay, we know when we get these terms, we're going to get an a involved somehow. So in order to find the value of this non-zero constant a, well, we can build an equation out of our terms. So in order to do this, we're going to need an x term, we're going to need an x squared term, and then we're going to need to equate the coefficients to calculate a. So we're working with one expansion. Again, if you can see it already, go for it. If not, let's think about what R would be. So for values of R, and here we're going to see some real magic. If we say the first position is going to be 7 minus R, but there is no x in our first position, he's gone. We have plain x in our second position, he's going to the R, and he's making an x to the 1, or coefficient of x. So what's really nice is if we have a number in the first position, and if we have a plain x in the second position, our R value matches what we're looking for. So R equals 1, and R equals 2 are the two ones that we want. Okay, so just going over that, if we have a number and a plain x, then our value of R matches the value of our exponent that we're looking for. So now we can go straight to what term in x. In R, so 7, 1. In the A position, we have a 2. So the 7 minus 1 is 6. In the B position, we have plus ax to the 1. So 7, 1 is 7. 2 to the 6 is 64. Ax. 7 times 64 gives us 448 ax. So our term in x is now ready for the next step. But the next step requires an x squared. So for term in x squared, we want 7, 2 now. 2 to the 7 minus 2 is 5. Ax all squared. Don't forget your brackets as they help make things go in the right place and make your exponents end up on the right things. So 7, 2 is 21. 2 to the 5 is 32. A squared, x squared. Combining everything together, 672, a squared, x squared. So this is quicker than doing term by term by term by term to find the terms that you want by luck. Okay, remember, we're always targeting only the terms we want. And in many cases, the memos for the questions, if you want full marks, you must only target those specific terms. You can actually lose marks by calculating irrelevant terms. So please don't do it. Please only calculate the terms you need. Get your marks and save your time. Bank it for something else. Right. We now have the two terms we need to build our equation. So we can do for value of A. We know that the coefficients of these two terms are equal. So 448A equals 672A squared. Quadratic, ladies and gentlemen. Quadratic means we need two answers. 0 equals 672A squared minus 448A. We'd factorize. We can take an A out, but how do we know what number we're going to take out from here? That was a really neat thing. Take your calculator and do 448 over 672. You're going to get 2/3, right? So this shows that we have common factor. If we then say what is the common factor, to get it easy, 448 over 2 equals 224. That means we can take out 224A. From 672, 224 taken out leaves us a 3A minus 448A divided by 224A leaves us 2. So, always solve your quadratic properly. A equals 0, A equals 2/3. But remember there was a line there in the question. The question said, find the value of the non-zero constant A. They don't write things like that for fun. Given A doesn't equal 0, therefore A equals 2/3. So it's really important that you take that step. Solve your quadratic properly, but then look at the information you're given to actually then state what your final answer is for A. A cannot be 0, A is 2/3. This is something that actually applies in a lot of other topics in your maths as well. You've always got to consider what are the restrictions on your answer when you're giving your answer. So always check if you've got something like that explanatory in the question, or if you're doing functions questions, if you've got a domain, because maybe that's also going to restrict your answer. So always keep that sort of thing in mind. Okay, back to binomials. Our next question comes with a part 1 and a part 2. In the first part, we're given nice straightforward expansion. Find the term that's independent of x. The second part brings in our second bracket. But take a note there that x minus 2 over x to the 6, he matches our first part. So there's something coming in here that's going to link things together and make life a little bit easier. So x in both positions. Let's pretend that we're not so sure about finding our r. So for value of r, let's make our trick work for us. In the first position, we have an x. He is going to the 6 minus r. In our second position, we have an x to the minus 1, because we're only considering the x and his exponent to the minus, not to the minus r, to the r. And we are building the term that is independent of x. What does that mean? That means there's no x there. Okay, if you're independent of x, you are not affected by x. So how do we write no x in exponent form? We write it as x to the naught. Because remember, anything to the power naught is 1. So we would be independent of x if we had x to the naught. Now we work through our nice exponent laws again. X to the 6 minus r, x to the minus r equals x to the naught. So x to the 6 minus 2r equals x to the naught. Therefore, 6 minus 2r equals naught, r equals 3. Now we are ready for that term independent of x. For term independent of x. Now we're using r, n, r, a to the n minus r, b to the r. So n is 6, r is 3. And she writes r. So 6, 3. x to the 3, 6 minus 3 is 3, minus 2 over x to the 3. Watch your signs so carefully when you're doing these questions. Okay, so 6c3 is 20. X cubed minus 2 cubed is minus 8 over x cubed. And we have that magic again. Our x cubes are going to cancel. So 20 times minus 8 gives us minus 160. In this case, they asked for a term. So we're not expected them to give the coefficient, we're just giving the term. There is no coefficient of x here because there is no x. Right, next part. Find the term that's independent of x in the expansion of all of this nonsense. So we have to think nicely. This we know is our expansion. Okay? This has 7 terms in it. How would we make the term that is independent in x? So we're going to say 2 times, 2 times, 2 times, 2 times, 2 for each of the 7 terms. And then we're going to do 3 over x squared times each of the 7 terms. We're going to be here for a while. And remember that we don't want to do everything. We only want to do what is necessary for the question. So we have to think what's necessary. Independent of x. Well, if we were to say 2 times anything, it would have to be 2 times the constant. Because that's the only way we can get a term that's independent of x. Here, this piece, we would have to multiply by an x squared term in order to be independent of x. And now we can see that we only have 2 pieces out of our expansion that we need, not all 7 pieces. Magically also, this is minus 160. We calculated it already in part 1. So all we need from our expansion now for this part of the question is the x squared term. So for x squared term of x minus 2 over x to the power 6. For value of r, we have x to the 6 minus r, we have x to the minus 1 to the r equals x to the 2. So x to the 6 minus 2r, we did it long-handed last piece, equals x to 2. Therefore, 6 minus 2r equals 2. So 2r equals 4 and r equals 2. So for x squared term, we want 6, 2. A position to the 4. B position to the r. 6c2 is 15. X to the 4. This is squared, so we go nice and even. So we have 4 over x squared. 15 times 4 gives us 60, and those cancel to give us x squared. Right. Now we are ready for our independent of x in all the nonsense. It doesn't take you long to write things out like this, but it helps keep your head straight and your examiner following what you're doing. So we said we need the 2 times the constant that we got up here in part 1. Plus we need the 3 over x squared times the x squared term. So 2 times 160 gives us minus 320, plus the x squareds cancel. 60 times 3 gives us 180, minus 320 gives us minus 140. So the term independent of x in all that nonsense is very simply minus 140. And that's what's so important, again, is that you haven't gone and you haven't done excessive amounts of calculations. You haven't gone and got terms that are going to be of no use to you. No marks, waste of time. So calculate only the terms you need. Think first, then calculate. Okay, right. We have 6 minutes left. And we have one more question, which is slightly different. So there's only a few questions that have come up like this in the past 17 years. But the thing is that every now and then they come up with something different. So it's good to do these different questions in order to stretch your brain a bit and make you think. So the coefficient of x squared in the expansion of this plus that is 90. Find the value of the positive constant a. So there's our a sitting, and it's another one of those, well, if we do it, we're going to get an a in there. We've got an is, which can translate to an equals, so we can build an equation and then find an a. So we would need the coefficient of x cubed. We would need an x cubed term from here plus an x cubed term from here. And then we would look at the coefficients and add them to 90. So take a little bit of time, understand the question, translate it a bit before you go for it. So, if you also notice, we've got that lovely format of number plus plain x, number minus plain x. So we can go straight to our value of r. So working with a plus x to the 5. For x cubed term, term in x cubed equals n is 5. R is going to be 3 because we had that number plus plain x. A is going to be to the 5 minus 3 is 2. And x is going to be cubed. So 5, 3. Is 10. So we have 10 a squared x cubed. Working with the other piece, 2 minus x to the 6. Term in x cubed equals, now our n is 6, but r is still 3 because we still have our beautiful format. So 6, 3. 2 to the 6 minus 3 is 3, minus x to the 3 is minus x to the 3. 6, 3 gives us 20. 2 cubed gives us 8, and this stays negative, minus x cubed. So 20 times 8 times a minus 1, minus 160 x cubed. So now we've got our x cubed element from the first, our x cubed element from the second. We can combine them and build this equation. So for term in x cubed of a plus x to the 5 plus 2 minus x to the 6, we would say 10a squared x cubed plus minus 160 x cubed. We've taken our x cubed term, we've added to our other x cubed term. This goes to 10a squared minus 160 x cubed. We've isolated our coefficient. Now we are ready to do for value of a, we told that coefficient of that x cubed, so 10a squared minus 160 equals 90. So then we bring everybody across, 10a squared equals 250, a squared equals 25, a equals, we are proper mathematicians, plus or minus 5. But remember, check your question. value of the positive constant A, given A is greater than 0. Therefore, A equals 5. So we take our square root, we get our two answers like a proper calculation, but then we use the information in the question to restrict our answers to give the single value that they've asked for at the end of the day.